Hello, I'm going to show an example of a quadratic function given in standard form. I'm going to find its 5 main features and I'm going to sketch it. And this time I'm going to do it using a little bit more technology than in the previous example because I'm using a tablet and a pen to draw on the screen. So I have to make up my quadratic function in standard form and I'm making this up. F of x is x squared plus 4x plus 5. So for the 5 main features, I'm going to begin by saying that the concavity is positive. And that's because the leading coefficient is 1, which is greater than 0. So this is going to be the shape of my quadratic. Then I'm going to find the y-intercept, because that's always very easy when we have it in standard form. We need to find the value of the function at 0, which is 5. So the coordinates of the y-intercept are 0, 5. And now I'm going to try to find the x-intercepts. I'm going to solve for x, the equation x squared plus 4x plus 5 equals to 0. This is a quadratic equation, so I'm going to apply the quadratic formula. Here a is 1, b is 4, and c is 5. So I have to find the result of doing minus b plus minus square root of 4 squared minus 4 times 5 times 1, all of that divided by 2, and you will immediately see that this cannot happen. We cannot find a solution for this because we have the square root of 16 minus 20, and that's a negative number, so it does not exist, so there are no x-intercepts. So let's see what we have so far for our quadratic function. We know that the y-intercept is here at the point 0, 5, and we know that it has positive concavity and it does not cross the x-axis. So it could be, well, if the vertex will be at 5, then it will be this shape, or it could be something like this, or it could be something like this. I need to figure out what the vertex is. And for that, what I'm going to do is consider a line going through the y-intercept. So the line y equals 5. And I'm going to see where, if at any point, my function cuts that line again. So we know it cuts it at 0, 5. I want to see if there is another point here, for instance, or here, for instance, where this happens. So, and if there is no such a point, then it means that the vertex is exactly there. So we need to solve for x. X squared plus 4x plus 5 is equal to 5. And of course, the 5's cancel. So we need to see when it's true that x squared plus 4x is equal to 0. And this is going to be true exactly when x times x plus 4 is equal to 0. I just factorize this. So we can apply the null factor law to say that either x is equal to 0 or x is equal to negative 4. So that means that the other point that is at the line y equals 5 and at my parabola, it has x coordinates negative 4. So that will be the point over here, negative 4. And that's the point over there. So let me erase the quadratics because actually those were just possible cases. But now we can say more about the quadratic, because if we know that the point 0, 5 and the point negative 4, 5 have the same height, it means if I were able to fold the parabola, those 2 points will coincide. So that means that the vertex and the axis of symmetry are halfway between those 2 points. So they had to be exactly at x equals negative 2. So there are 2 steps between negative 4 and negative 2, and there are 2 steps between negative 2 and 0. So I'm going to sketch my axis of symmetry over here. It has to be there so I can fold the parabola and make the 2 points with y coordinate 5 coincide. So this is x equals -2. So that means that we found the axis of symmetry. Has equation x equals -2. And it also means that we can go ahead and find the coordinates of the vertex. We know now that the x coordinate is -2. So we need to apply our function to -2. And then we're going to get -2 squared plus 4 times -2 plus 5. So this is 4 minus 8 plus 5. So this is 1. So the vertex has coordinates -2, 1. I'm going to add that to my picture with the smile to show that the concavity is positive. And now I can go ahead and sketch the parabola. That's how it looks like, the parabola y equals x squared plus 4x plus 5.